Hey, it's Brent. In this video, we'll cover some common anhydrous system questions and things that you should look at prior to the seeding season. Let's get started. The first thing we want to do whenever we're working with anhydrous is make sure that we have the proper PPE and that the system is completely drained or empty. Make sure that our tank is disconnected or all the valves are turned off and we've opened all the bleed valves to exhaust all of the anhydrous ammonia from the system. From there, a great thing to do before season is to clean our strainer first and foremost. To do that, we'll move over to our strainer. We'll make sure that our emergency valve is closed. We'll remove our strainer cap. We'll clean the mesh strainer as well as the magnet, clear any debris from there, and then put it all back together. After cleaning our strainer, it's a good idea to take a look at the condition of the rest of the cooler. The thing that you'll look at here on this cooler is you'll see some of our lines that are going out either to our delivery tubes or to our vent lines, as well as our line that feeds our vent. So here's our line that's feeding our vent. That's what's actually cooling in the cooler. This is our delivery line. And this vent line, along with our vent line on the back of the cooler, is where the vent goes out to, and that excess product or product used to vent is delivered to the ground. So we look at our delivery line, we want to make sure that it's in good condition and it's not going to have any leaks that are going to cause us issues throughout the season. We also want to look at our vent line that provides coolant to the vent. And finally, we want to check the condition of our vent lines, not only the condition of the hose itself, but also whether or not that line is free and clear. We want to make sure that our vent line is open completely and that there's no obstructions that would cause that vent to be plugged up or for anhydrous to not flow through it. Since it's what cools our system, we want to make sure that that goes directly through a line to the ground and not through a delivery tube. We want to have no back pressure on that line. You'll see in the example of this drill that our vent line is coming out and is ran separate down to the ground through its own separate line. Again, make sure that that vent line is not plugged, obstructed, or running into a delivery tube, as that delivery tube can cause back pressure. We want to inspect the rest of our lines as well as our dividers. Make sure that our dividers are in good shape, that all of our connections are good, all of our lines look good and tight. From here we can see that this cooler is run by a Green Star array controller. We'll take a look inside of the cab at the configuration of this Green Star array controller, but before we do that, we want to take a look at our valve configuration. We really have two options for a valve on an anhydrous system. Either we're going to have a standard valve configuration, which is what we have here. It's easy to tell because a standard valve is going to have two valves, a control valve and an on-off valve. Your other option for an anhydrous valve configuration would be a fast valve. The easiest way to tell if you have a fast valve configuration is you won't have an on-off valve next to it. You can also sometimes tell by the sticker on the valve if it's still there. So if you have a fast valve, you won't have an on-off valve, as the fast valve will regulate the rate of the product as well as turn it on and off. Finally, before we enter the cab to look at our rate controller configuration, we want to take a look at our flow meter. Our flow meter is going to be stamped with a calibration number. We can see here that this flow meter cal number is 720. So we'll remember that number as we enter the cab. Now that we're inside the cab, we can take a look at our rate controller configuration and verify our settings. To look at our rate controller on our Gen 4 display, we'll go to ISOBUS VT, choose our menu, and choose Green Star rate controller. From here, we can check the configuration of that rate controller to ensure it's correct. We'll go to our arrow pointing at the dot for setup, verify our implement width and number of sections. From here, we'll choose our system tab up on top. In our case, we have a standard valve. Since we have a standard valve, we'll choose our control valve type as standard. You can see our control valve calibration number is 2513. If you remember from the video prior, the control valve calibration number on the valve is 2123 per Raven. In this situation, per our operator's manual for the Green Star rate controller, we want to use a control valve calibration number of 2513. We'll enter our tank capacity over here on the right, whether we want our tank capacity displayed in a percent or in pounds, and then our tank capacity units in either pounds or gallons. Below that, we see our flow meter calibration number. You remember from the tag outside, our flow meter was tagged 720. Remember that all Raven flow meters are tagged in a denomination of 10 gallons. So our 720 is not 720 gallons, it is 720 10 gallons. You'll want to ensure that you have that correct. Our next tab is alarms. We can set alarms for our low tank level and a high-low rate alarm. And finally, we have our rates tab. Under our rates tab, we can choose whether or not we want to see our rate in actual pounds of nitrogen or if we want our rate in actual pounds of product. Make sure that when you're doing the configuration that you note whether it's in actual nitrogen or actual pounds of N, especially if you're applying a prescription that someone's written for you. Make sure that your rate units match. Here's a rate smoothing of 3%. That's the standard number. That rate smoothing is going to tell the rate controller if it's within 3% of the rate to display the rate to you as the operator. Another easy way to tell what your rate units are is from your main implement page. Under main rate controller button, you'll see the rate here is in pounds of N per acre. So in this case, our rate is set to 70 actual pounds of N per acre. You do want to make sure that you have an operational height sensor on your Anhydrous tool to ensure that you don't get any unintended flow while anybody's outside and the tool is up. Any diagnostics for it can be found under our book and wrench, the test tab. From here, we can do a control valve test to make sure that our control valve is able to move. We can do an energized system without any anhydrous connected. We're safe to do this even parked in our yard. Make sure again that our system is bled completely and that there's no anhydrous present. We can override the height switch, turn our master on, and press start. By doing this, we can have somebody outside to listen and make sure that all of our valves open like they're supposed to, close like they're supposed to, so when we get to the field, we'll know that everything is operating properly.
Thank you for watching. Connect with us by subscribing to Precision Ag Answers on YouTube and following RDO Equipment Company on social media. Visit rdoequipment.com for more precision ag resources and solutions.